Hello viewers and welcome to another STM32 tutorial video. Now, I suspect this video is going to be fairly short and I have been debating myself whether I should bother to make it. But I think it is actually necessary to mention this. Now, all these tutorial videos are using standard C to program the STM32. But it's quite interesting to look into the variable types, the C types, because they differ from platform to platform. And if we look at the original C, which was written in the mid-70s by Dennis Ritchie, uh, it no, sorry, C was that was the Unix kernel, but Brian Kernighan wrote C in the mid 70s, 75 or something like that. And originally there wasn't a specification, but together with Dennis Ritchie, he wrote a book in 1978 called The C Programming Language. And this book is, in my opinion, a must read for anybody wanting to write a single line of C code. Read the C programming language. It's a good book, and it explains a lot of things around C. One of the things it goes into is the variable types in C. It's down here in chapter 2 in the book, the C programming language. And it's interesting to see there's only a few data types in C. There's a character, which is a single byte. There's an int, float, and a double. Now, the int is interesting because it is defined as an integer, typically, notice the word typically here, reflecting the natural size of integers on the host machine. So it would be expected that on a 16-bit processor, it's 16-bit, and on a 32-bit processor like the STM32, it would be 32-bit. But the interesting part here is that it's actually not specified in the standard. Later specification probably have it. And you will have noticed in a lot of the code I'm writing, we can take, for example, the last one here. I tend to use these int16r, so that indicates that this is a 16-bit integer, the sign, or an unsigned 8-bit integer. I tend to use those a lot. The benefit of that is that if you do a library, if you implement a library, for example, that is meant to run on different platforms, this one forces the size of the variables. But a simple fact is that an int, which is one of the basic types, does not have a fixed size. So really what I'm going to write in this particular tutorial video is something everybody should try for themselves. And that is basically, I've created a basic project here that is doing nothing except printing out starting. Oh, that was the wrong one I ran there. Sorry, this one. It is doing nothing but printing out statement. It doesn't even have the main loop in this one. But what I wanted to do is I wanted to do something like this, just to verify. We can print out the sizes of various types. So if you take this, we can say a size of a char equals, and then we use the sizeof function or operator. It's actually an operator. I think you can. Can you actually write it like this? I think you can. Sizeof. No, it wouldn't compile. Never mind. I think sizeof is actually generally considered an operator. I don't know why. So there, if we run this, you'll see that now it prints out size of a char is 1 byte. Sizeof return the size in bytes. So we can now verify our suspicion that an integer would be 32-bit by adding this line. and it is indeed 4-byte or 32-bit. Now, using this exact approach, we can go through some other types we have in STM32, which is not the fixed one, but now we'll do those first. So we can do a character, a short int, which according to Kernighan and Ritchie, where is that? The intent is that short and long should provide different length. So the restriction is shorts and ints are at least 16-bit, longs are at least 32, short is longer than int, is no longer than int, which is no longer than a long. So we have a short int, we have an int, we have a long int, we have a long int, we have float double, long double, we have, and this well-specified ones, we also have a void pointer, which is a pointer to something. Let's try to run this and see the output. Here we go. So a character is, as we expect, 1 byte. A short int is 16-bit or 2-byte. A int is 4 bytes or 32-bit. A long int is actually exactly the same. So it is not a 64-bit. A long int, though, is a 64-bit value. We have floats, double, long double is exactly the same as a double. I don't know. Can we actually, now I'm getting curious, can we actually do a long double? I don't know, but let's try. It should be, the syntax should be acceptable. So let's try to run that. No, it didn't like a long double. Fine. Didn't expect that. And we have our fixed sizes down here. The 8-bit one, which is 1 byte, the 16, which is 2 byte, and we can actually define a 64-bit integer, which is the same as a long. So that's pretty much all I wanted to go through. It's just to have an idea about these sizes, and it was slightly surprising to me in the beginning that an int was actually a 4-byte or 32-bit value. I would have expected an int to be 16-bit. But, well, everybody should do something like this. Even if you're watching this video, try to do this implementation on your own platform. I guess this could differ depending on what compiler you're using. I'm using STM32 Cube IDE, which internally is using GCC, but it could be if you used a different compiler that you actually get different results in this, and it is something you should try, and it's something that you should know. As usual, if you like this video, please like and subscribe, and please comment below. I'm not a C expert, so I'm fumbling along with this as I'm learning, and so please comment below if you have more experience than I have, and have a wonderful rest of the day.